There are a couple of different ways to calculate work. In reality, with all the different ways work can be done, there are several, I suppose, but we will focus on two main options for calculating the work present. The first option is to use the conservation of energy equation. And we've used that energy equation a few times now where we've said, hey, the total initial energy equals the total final energy. I'm just now adding in this plus work. So the total energy in the beginning plus whatever work is done by objects outside the system will equal the total final energy. And if we know the total initial energy and the total final energy, well, we can solve for the work. Um, in fact, I'm going to pause the video and I'll just shove that in there right now. So here we see then total initial energy plus work gives us the total final energy. If we just rearrange and get work by itself, so I want to move this total energy to the other side, total initial, and subtract total initial on the other. Oh, jeepers, I put the wrong sign in there. World. That should be a minus. My apologies. Bloop. There we go. Um, now we'll go back to things. Here we go. So now we say if I subtract total initial energy from this side and I subtract total initial energy from the other side, then I have work on its own. So I have work equals total final energy minus total initial energy. That work done equals the change in energies of that system. And that work is done by some object that's outside of our system. The example that we did on the previous page with the little cart going around gave us something like that. The second option for trying to calculate work is another common way to go is to say that work is the average force times the change in position. Remember this triangle D is, we read this as either delta D or change in D. This is the displacement, it's the change in position. So it's like final position minus initial position. So the another way to calculate work is to take the average force that this outside object exerts. So like the spring on the previous question, we could take the average force. We could take the average force that the spring exerts on the system times the change in position of our system, which would have been that cart. So we can go through and do that to calculate work. And then if they're both in the same direction, like if the force that the spring exerts is to the right and the car moves to the right, then our work is positive and we've increased the energy of our system. If the force is to the right and the change in position is to the left, then it's negative work and we've removed energy from the system. So if our spring is over here and the car comes at it and the spring slows the car down and makes it come to a stop, well, the spring would be pushing that way, but the car is moving that way. So in that instance, the object outside of our system, the spring, would be doing negative work, removing the kinetic energy from the car, track, earth system. So negative work is done when the total energy decreases or when the object pushes in one direction, but the system moves in the opposite direction. That's a common way to go with that. We'll look at one more example here in a second that looks at everything being in our system except for the Earth. So we're still saying everything exists. We're just saying that we're going to analyze it as though the Earth is outside of our system.